Hello and welcome to our third section on designing studies. We're going to talk about using studies wisely. There's not a lot of numbers or math involved. It's more definitions and things to be aware of for studies. All right, so we're going to talk about scope of inference. We're going to talk about the challenge of establishing causation. We're going to talk about data ethics, and then we have some bonus information at the end, and just two homework problems. All right, so we want to distinguish between, this table distinguishes between random selection for a study and random assignment to groups within the study. So I'm going to give you this table and an example. And the example is a 2-drug study where individuals are placed in 2 treatment groups plus a placebo group, and where they're randomly selected for the study. Let's say the sample of the population is randomly pulled, and then random assignment to treatment groups of that population that's pulled for the study. Then that group itself is assigned to the specific treatment groups. If we have some random selection for a study and then not random assignment to treatment groups, it might look like a random pull from the population. But then once they're into the study itself, then people self-select into the drug of their choice. Or we could have self-selection for the study itself, and then a random assignment to the specific drug. Or the fourth option is we have self-selection for a 2-drug study and then self-selection into whatever drug that the people in the study want to take. All right, so we want to distinguish between selecting for the study, random assignment for the study, and random assignment into groups within the study. And that's going to mean some different things in terms of what we can infer. If we randomly select for the study, then we can make inferences about the population. If we randomly assign to treatment groups, then we can make inferences about cause and effect. And then if we don't, then we can't. If we don't randomly select for the study, then we can't make an inference about the population. We can just make an inference about the people who are in the study. And if we don't randomly assign to groups, then we can't make an inference about cause and effect, because the self-selection might create some bias or skew in the data that would negate the cause and effect. All right, so let's talk about random selection to study. So again, if individuals are not randomly selected, then a self-selection bias or some other bias may result. If some group were predisposed to poor performance after sleep, were selected because they volunteered, then inference about the population is voided, because the study would only study people who had issues or poor performance after sleep. If we don't randomly assign to groups in a study, then even though the individuals were randomly selected, there might be some hidden bias in a group that was skewed towards one result. For example, I decided to take some drug, and this particular drug I knew something about it, and I knew it was going to help me, so I took that drug, and I knew the other drug wasn't going to help me because I had previously tried them. So self-selection might create some bias also in the study that we're not aware of, or some other lurking variable might be there based on self-selection. So we can't make an inference about cause and effect. All right, so here's an example of inferences in random assignment. So students say that they study better while listening to music. They create 4 possible studies with a response variable as students' GPA at the end of the semester. What can they infer about the following studies? So the first study is all students in the AP class are selected for the study, and they are asked if they listen to music and are grouped based on their answers. All right, so I'm going to give you the answer to this. So there's no random selection, meaning we just took students from the AP Stats class, and then they were grouped based on their answers, so there's no random selection there. And so with no random selection, the results of the study should be applied only to AP Stat students. With no random assignment, we can't conclude anything about cause and effect. All we can conclude is that AP Stat students who listen to music while studying have a lower GPA potentially than those who do not. And that was what was found for this particular study. All right, so this brings us to our first homework problem, 4.3.1. So this is the same study, but now you're going to select a random sample of students from the school, and you're going to give them a survey about whether they listen to music and then divide them into groups based on their answer. So take a minute to copy this down. I'm going to pause here. And then we are going to move on. All right, so we're going to talk about the challenge of establishing causation. Okay, so there are a bunch of challenges to establishing causation. A very big one is the lack of realism. And that's typically because we need to eliminate lots of variables. Then we have to create specific environments. And in those specific environments where we're testing something, then the overall environment, the dynamic nature of subjects, and what's happening typically are not realistic. So because studies sometimes are conducted in a lab or conducted in very controlled settings, it's hard really to mimic a real life setting because we're trying to control variables. So here's an example. A randomized comparative experiment with third brake lights. So this is when we only had 2 brake lights in the back of a car, showed that third lights in a car decreased rear-end collisions by 50% when compared to cars without a light. But then when the law was passed to have a third brake light in place, and the third brake light was in place, then collisions were reduced by only 5%. So what happened? Was it the brake light that caused the reduction in rear-end collisions, or was it something else? And here we see that it was something else. There was some effect, but it wasn't as substantial as was originally thought. So what happened was, when there was no requirement for third brake lights, the third light was an anomaly and it stuck out. But when all cars require the light, the novelty was eliminated, and then the accidents normalized. So the novelty of the third brake caught other drivers' attention and helped the initial decrease, but not really the third brake light itself. All right, so when we establish causation without an experiment, there are some things that we need to consider. One, is there a strong association? And so there's an example between, smoking and lung cancer. So there's a strong correlation between smoking and lung cancer. People who smoke more are more likely to get lung cancer. The association is consistent. We have studies of different kinds of people in many countries that link smoking to cancer. A larger value of the explanatory variable is associated with larger response variable. The more people smoke, the more likely they are to get lung cancer. The alleged cause precedes the effect in time. Smoking precedes getting lung cancer generally, and the alleged cause is plausible. It's plausible that if we take smoke into our lungs, it's affecting our lungs in a certain way that makes it more likely that that disruption will cause some abnormalities in cell reproduction. So there is a way of establishing causation without an experiment, but there needs to be this criteria that's in place. All right, so let's talk about data ethics. Sometimes it's not possible or ethical to conduct an experiment. So, for example, does texting while driving increase the risk of having an accident? We don't want people to increase the rate of texting while they're driving. Does going to church regularly help people live longer? So we don't want to force people to go to church because some people might not want to. So the study would have to be self-selected. Does smoking cause lung cancer? Again, we don't want to impose some treatment that might cause damage to an individual. All right, so basic data ethics, things that need to be considered as part of any study. All planned studies must be reviewed in advance by an institutional review board charged with protecting the well-being of the subjects. 2, all individuals must give informed consent. And 3, all individual data must be kept confidential. So these are basic criteria for managing data ethics for any study. All right, so this brings us to homework 4.3.2. So in your opinion, and based on what I just said, is it ethical to use animals to test new cancer treatment drugs? Is it ethical for researchers to want to determine bias in the hiring process by sending out equivalent resumes to several companies of male and female applicants and then determine how many male and female applicants get interviews? So I'm going to pause here while you write this down, and then we are going to finish up with my bonus set of information. So please copy or pause. Okay. So last thing is framing questions and response bias, which means the way we ask questions may result in some bias. So we have to be aware of how we're framing questions so we don't elicit a bias. So here are a couple examples. Do you find women who wear makeup attractive? That type of question, if an interviewer wears makeup, tends to receive a greater yes response and a lower yes response. If a greater yes response if the interviewer wears makeup, and a lower yes response if the interviewer does not wear makeup. And then around cartoons, if someone says, do you watch cartoons? 90% of the people say yes, and 60% of those people who are surveyed, if the question was framed, do you still watch cartoons? The still word makes it or implies that it's an association with some activity that would happen when you were younger. So the response is going to be, or the response for that survey was less. All right, so that's it for our discussion about using studies wisely. We just had those 2 homework problems. Again, not a lot of math. You can finish this up and come back when we talk about probability in the next chapter, chapter 5. Again, thanks for joining.